I'm going to start by introducing us, but then to sort of set the scene a bit before we kick off the discussion, we're going to hold a discussion probably for about 30, 40 minutes around a few topics. We're going to cover expectations, materials, retrofits, and some practical actions. And then we'll open the floor to questions. So we should have 20, 25 minutes or so for Q&A. So no pressure, but if you can start thinking of questions now so we don't have to sit in silence, that would be very much appreciated. My name is Will Arnold. I'm head of climate action at the IStructE, for those of you who don't know me. My job is to help lead the institution's response to the climate emergency. So trying to put that action into everything we do as structural engineers and everything we do as an institution, from setting standards to the publication of best practice guidance. I'm joined tonight by, like I say, three panelists who have all travelled quite a long way for this. So please make them feel welcome. On your left, the far end from me, is Dr. John Orr, who is a university assistant professor in concrete structures at the University of Cambridge. And his teaching and research focuses around sustainable construction, structural optimization, things like that. Next in line, we've got Steve Fernandez. Steve's the director now. He's the firm's UK leader for buildings retrofit, and he leads multidisciplinary teams across a range of projects across the UK and Europe. And then finally, Natasha Watson, who's a practicing senior structural engineer at Bureau Happold. As part of her work, she also consults on embodied carbon and other impacts of building materials and structural designs, and is currently in the midst of trying to help set up a Bureau Happold embodied carbon consulting team, I understand, which sounds very exciting. So in a minute, I'm going to open the discussion with our first question. Before I do that, I'd just be quite interested to know who all of you people are. So we're going to do a show of hands, if that's all right. You don't have to speak, don't worry. Could you please put your hand up if you're here tonight as an IStructE member? Okay, so good, about 3/4 of the room. Can you put your hand up if you've been dragged here by an IStructE member? And then if you've got no association with the institution at all, but you've heard about it through another means. So that's the remaining quarter. So okay, thanks. That just I'm just kind of curious, to be completely honest with you. So before we start the sort of conversations now, I'm going to open with a question that I've shared with the panelists in advance, which is why it's going to be all very slick, and just to sort of try and set the tone for the evening. And then we'll start working our way through our topic. So the question is based around the fact that we're in the middle of a period of major change across all industries, and the commitments you've heard in the last 2 weeks at COP sort of reflect this. So we've had 190 countries commit to ending coal power, 100 countries committing to reversing deforestation, and 90 countries pledging to reduce methane emissions. So really big change. But if you step back for a minute and look at the context within which that's all being done, I think you can it's quite easy to forget how much action needs to happen in the short term as well as the long term. So greenhouse gas emissions have been rising year on year since the start of the Industrial Revolution, and the world's been heating up at more or less the same rate. So we're trying to reduce carbon to slow that heating. That's agreed. The big drive that we've been hearing for a few years now is the need to do two things. That's to halve emissions by 2030, and then to get them down to zero by 2050. And a lot of what we've heard about in the last couple of weeks, frankly, has been quite long-term ambitions, long-term pledges, long-term commitments, which are necessary. But for this evening, I'm going to ask you to put those to one side and just think about the short-term 2030 halving of emissions, because that's the really hard bit, right? 2030 is 8 months. No. That would be shocking, wouldn't it? 8 years, 1 month and 19 days. I knew it was a good job. I wrote those down. 8 years, 1 month and 19 days away, which is not very long. Most of us will probably still be working, at least in some form, within that time. You've got to halve emissions in that time scale, which is quite a big ask. So the question I'm going to start tonight's debate with is that if the built environment is going to halve emissions in that 8 years, 1 month and 19 days, what change do we need to see happen between now and then? I'm going to invite John to start.
Great, thanks, Will. Hopefully people online can also hear and see. So I'll give you a couple of minutes of my thoughts. I think we all agree that if we're going to avoid the worst impacts of climate change, then we need to have significant change in every aspect of our life. And so I think my first point is that this is a very positive message. This is an opportunity to really change in a positive way what we do, rather than bashing ourselves over the head for doing bad things. Let's do something, let's make it a positive story. So I think that's the first thing I'd like to say. And it's an opportunity for designers. So we have all the tools we need. I should sit closer. We have all the tools we need to get to half our emissions by 2030. We just need more design. And so the strap line that we have in one of the IStructE books that's coming out is more design, less material. So that's one thing that we can all think of. Now that's really easier said than done. As Will said, we've all been educated and worked in this era of ever increasing emissions. So when you draw the slope of the IPCC emission goes up like this, and then the pathway is down, it's like a ski slope down. And that again is big change in everything that you do. So challenging everything, however small it is an important part of what you're doing, and therefore have a bias for action. So don't just say, oh, we've always done it this way, so I'll carry on doing it this way. Don't wait for the perfect answer to come along. There are no perfect answers. So have a bias for action, do something, see if it works, and if it doesn't work, do something else. But you need to do something, because as Will said, luckily we have more than 8 months, we have 8 years left, but we don't have much time at all. And that bias for action just leads me on to my final point, which is about something which you will have heard lots of over the course of COP, which is breakthrough technologies. Sorry, I lost my voice a few days ago, I'm just recovering. Breakthrough technologies that are going to come along and save us, particularly things like carbon capture, utilization and storage. They are not going to come along and save us. We cannot rely on those breakthrough technologies, okay? So we have to do things what we already have. And the problem is that if you're a policymaker, it's really attractive to say that a breakthrough technology will come along in 20 years' time, because you can promise that, and you don't have to do anything today. And that's why it's a favorite of policymakers. We're not policymakers, we need to do stuff today. And it's why climate change is what we call a super wicked problem. It's not just a problem, it's a super wicked one. And I've even written down what that means. Time is of the essence. We don't have much time left. The people who created the problem are also trying to solve it, that's us. There is no central authority to solve the problem, despite what we might hope from COP, it's not a central authority. And we have what we have described as irrational discounting, that kicking the can down the road. So I do think this is a really exciting time for designers, lots of great things we can do. And I'd like to finish with that positive note of optimism rather than pessimism. Thanks.
Thank you, John. And I like challenge everything. I feel like I might get that put on a poster somewhere. Steve, what are your thoughts on the same question?
So I'm going to talk about building retrofit or refurbishment of existing buildings. Why is it important for us to retrofit our existing buildings? And this is something that over the last few days and over COP, a lot of people have been talking about it. The reason why retrofit is so important is because demolishing existing buildings and constructing new ones, this really does contribute towards the climate crisis. Why is that? So demolishing and rebuilding, this means that we extract more raw materials. This increases the carbon emissions, and it also increases waste. So when we demolish our existing buildings, waste is created from the existing structure, from all of the components that make that building, and also the foundations. And this is something that has previously been overlooked. And we know that construction, it's responsible for over half the world's extraction of virgin resources. And also construction, it contributes towards 60% of total waste streams across the world. So, you know, it's really important because retrofit, this saves all of that embodied carbon in the existing building. It reduces the extraction of those virgin materials, and it also minimizes waste. We know that with predictions, 87% of today's buildings, they'll still be occupied by 2050. So we've got all of these existing buildings and we have to improve their performance. So I believe that it's time for radical change, and on a dramatic scale. You know, we all have a role to play here. Refurbishment or retrofit, it's not a compromise. And I found that tired structures, they can be reinvented, and transformation, it can be realized through innovative interventions. And this is where we all have a role to play. So you all in this room and everybody watching online, as designers, as engineers, and as architects, we have a key role to play. So many of the clients that we work with and building owners, they may think that they need to demolish and rebuild their existing buildings. And this is where our role is key. We have a vital role to challenge this. This is where imagination is needed at those early feasibility stages. So this is where we need to get involved with clients at that early stage when they're trying to decide what to do with their existing buildings. You know, we can then help to identify the potential within the existing buildings and really help to use our imagination and repurpose them in a clever way. And again, look around. I think it's important that we all need to look around at what others are doing. Don't look very inwardly at what your own organization is doing. See what others are doing. And you'll see that it is possible, not just to refurbish existing buildings, but they can be successfully transformed and reused with both functional performance improvements and operational improvements as well. You know, this is really important, and this is how we will achieve those net zero targets. They're really ambitious, and we have to do so much more with our existing buildings. And looking at examples and being bold and brave with our decisions, we can justify not having to demolish existing buildings. So I believe that retrofit, it's an essential part of the jigsaw. If we are to achieve the ambitious carbon target. We have so many existing buildings, and as I said, 87% of today's buildings, they will be occupied by 2050. So we really do need to do something about repurposing existing buildings. So I think for me, my message to you is look around, be bold, be brave, and try to do something more with existing buildings.
Thanks, Steve. So good. So actions to get to half by 2030. We've got challenge everything and reuse more. I hope, Natasha, you're going to be able to give me something that I can also distill into 2 words.
Well, for me, I think that we need to blend our values as individuals with our values as engineers. COVID was an uncomfortable blend with us working from home. Our work life and our home life, for some people, was a really uncomfortable mix. There wasn't enough of a differentiation. But for me, it was actually quite a welcome discomfort. It was a way of me being able to appreciate my whole self, and with things like Black Lives Matter, with the climate emergency, understanding that those things are important to me and they should translate into my design. A building, as a good friend of mine, Dr. Ellie Cosgrave, said, has a political purpose, has a political impact. And I think that gone are the days when engineers have to be cool, passive, kind of bystanders and waiting for the brief to be developed, waiting for the architectural problem to come along for us to do structural gymnastics. We really need to bring our values to our design. And I think that if you've got that there, then you've got, as John said, we have the technology, we have the education, we have that. What we need is the love and the care from yourselves as designers to really push that along. And I think that's what we need between now and 2030.
Thanks, Natasha. So I can't get it down to 2 words, but I think
Sorry.
take your values to work.
Yep, I think
Okay,
so.
good. Thank you, all of you. So hopefully that sort of set the scene a bit for as much what your 3 panelists are like, if nothing else. Let's start by talking about the sort of change that we expect to see coming in the next 3 years. You've all touched on the sort of change you think we need, but I think it's just as important to talk about what we think is sort of coming even in the next year or two. I'm going to start with you, Steve, because you've already touched on the fact you are big on retrofit, big on reuse. What are your thoughts in terms of the clients you work with, the briefs they set? How are these things changing? What are you seeing change in your work?
I'm definitely seeing a massive shift, and I've been passionate about existing buildings for many years, and in the last 2 years, I think the pendulum has swung, and whereas before working on existing buildings was something that a small group of people did. It was perhaps less glamorous. What I've seen is this massive shift where we're doing more and more work with existing buildings. And I think, you know, some of our clients, they are educated. They understand that retrofit is important if we want to achieve the ambitious carbon targets. And they understand. So we're carrying out carbon calculations. And what those calculations prove is that reusing an existing building is always going to be much better than a new building. So if the client, they may have an ambition to achieve a very low carbon building, the best solution is to keep something that's already there. You know, don't actually do anything to it. The important thing is that existing buildings have to be adapted. They have to be upgraded. You know, we have quite difficult targets to achieve, you know, with overheating, with losing heat as well. So I think there's two sides of it. The climate crisis is here. We're finding that our summers are hotter, so our buildings get hotter, but also a lot of our buildings are leaking as well. So there's a huge amount that needs to be done to improve the fabric of the existing buildings. And I think this is where clients are starting to appreciate that. You know, with the government release of, you know, introducing air source heat pumps this week, you know, last week, that's a really big step, and it's a bold step. But it's not just about changing the energy source. It's about looking at the entire building. That it's a fabric first process. You know, we need to think about how the building performs, and you can then incorporate these sustainable technologies, but you also have to improve that performance of the building. And I think this is where we're definitely seeing a shift. And we're also finding that people actually realize that existing buildings are important. You know, they're part of the character, they're part of our history, and that's where it's important to celebrate those buildings. You know, a really good example is around the King's Cross area, and projects like Coal Drops Yard, the transformation of King's Cross. You know, these are iconic structures and buildings, and that history is actually celebrated, and it becomes a characterful place. And the area has been transformed. So I think this is where it's not just about the building itself, it's about the wider benefits and the benefits to society.
Yeah, I've got to say, as I was walking through Glasgow to get here today, I was thinking about, you know, the huge amount of, you know, building stock and history and heritage that exists in this city. It kind of really drew it out for me. So it's interesting to hear you say that, you know, clients are asking for more retrofit, they're asking for this, but it sounds like you're also saying that as engineers, we're having to explain to them what that means and how you go about doing that. And I just wondered, Natasha, from a sort of new build point of view, are you having the same, you know, are there parallels there with what you're finding with your clients?
Yes, so with new build, we are having more and more clients come up to us and ask us, you know, what are the embodied carbon impacts? Some of those clients have signed their own net zero by 2030 targets. And a lot of it is talking to them about how net zero is, you have to balance your carbon emissions that you emit through your building of your new building with the amount you want to purchase to offset. My opinions on carbon offsetting are probably for another day, but if you reduce the amount of embodied carbon that you're going to create with your new building, then you minimize the amount that you need to offset by. So there's a very strong monetary argument to tell our clients. And also the reason that they've signed those net zero commitments is because that's where the money is coming from. So it's changed because now it's not just about morality, it's about business as usual. If they want to continue their businesses, they need to get on board with this kind of thing. And we are talking a lot more about things like retrofitting with a project that I've worked on recently. The client had not necessarily considered reusing as much of the building as they now are planning on doing so, because thankfully Camden County Council are very forward thinking, and you have to have a very good reason to demolish a building now. So even though, yes, it's not 100% retrofit, we're definitely seeing more and more of that. And then when you're reusing things like substructure and basements, then it makes sense to have a much more structurally efficient building on top of that, so that they can get the floor areas they need. So then that's really sort of entering into the realms of efficient use of materials. lighter weight materials such as timber as well.
Yeah.
Can I just add to that? I mean, I think, you know, the important point to make is that, you know, whilst I'm a strong believer in retrofit isn't always the right answer, but I think this is where we have a role to play, having those early discussions with the clients and just challenging, testing the options. What options are there? Can you reuse the entire building? Can you reuse part of the building? Can you reuse the foundations? You know, and I think as long as we're challenging the perception and that we've explored all of those options, if the solution is to construct a new building, I think we need to make sure we've gone through that entire process. And this is where I do believe we need to be involved at the early stages of those projects, you know, almost at project creation. You know, the majority of you are structural engineers, you know, often we get involved at, say, REBA stage 1, but actually we should be involved at REBA stage 0 at, you know, the inception, where it's just idea selection, trying to understand what can be done, what can be achieved. And this is where there's a real change in mindset, as was said earlier, you know, not waiting for the architect or the client to say, this is the brief, here you go off and design it. We have an influencing role to sort of pave the way for our clients and building owners.
And I think a lot of engineers might even argue that they'd be lucky to get on board at REBA 1, and you know, REBA 2 or 3 might be more common. So, you know, I think we definitely understand that point. Interesting to hear you also sort of put it in the context that, you know, clients now, to them, this makes business sense to try and, you know, do low carbon, whatever that means for the particular situation they're in. I'm going to go back to, I know you said you don't want to go into offsetting, but I think we do have to talk about offsetting, because it's going to just be it's going to be an elephant in the room, otherwise it's not that big a room. So John.
Yes.
So John's just led the authoring of a book called Design for 0, Design for 0. I should know because I did help. And we do touch on offsetting in the book, right? And when we first started writing it, I remember that there was at one point in time it was going to be let's not talk about offsetting, let's just sort of say it's bad and we won't go there. But I mean, my opinion has always been, well, actually, it's not going to go away. And for as long as we're talking about net zero, which is, you know, balancing your emissions with some form of offsetting, it's better to do it right than to just sort of, you know, shun it completely. So I'd be interested to know if during the process of writing that book, your views have changed, or do you just still think it's really evil and
I certainly don't think it's evil. I think my difficulty with offsetting generally comes when people use it as a reason for business as usual plus offsetting, and that to me is the worst possible approach. So first of all, don't do that. This is not a question of you can do whatever you like and then offset by, you know, planting trees or changing stoves in other parts of the world. That doesn't work on a global scale. You can't do that. Not everybody can do that. That's the first thing. So long as we're offsetting appropriately at a late stage, so the hierarchy is use less stuff, specify appropriately, and then right down the bottom in tiny letters is offset appropriately, I think, something like that. So long as it's late in the day, late in the design stage, and you're doing it properly, I'm okay with it. And when I say doing it properly, I mean offsetting that is aligned with the Oxford offsetting principles. Desperately trying to rack my brains for what they are. I can't remember, but there are good offsets and bad offsets. Let's put it that way. So make sure you're following a scheme which is properly audited and so on. So I don't mind it, but I do mind it when people say, "Oh, we'll just make loads of cement and then offset," because that doesn't work.
Yeah, I agree. I think we'd all agree.
There's a very good phrase which I like to use, which is when you essentially business as usual, but you've got a lot of money to offset it. It's called toff-setting. So yes, use that when you want to.
No, I like that. I'm glad we've talked about that, because I think, you know, if we're going to try and talk in the context of now to 2030, it is still going to be here. I think, you know, longer term, when we talk 2050 and when countries have an aspiration to be quote unquote net zero by 2050, what they probably actually mean is absolute zero by 2050, because as you put it, on a global scale, you can't all offset for each other's emissions. It doesn't make sense. There's a mathematical difficulty there, but in the shorter term, I don't think it's going anywhere. So as I've got your attention anyway, John, so in terms of what you're saying in the academic world, in terms of you know, we're going to need a whole load of different solutions on top of all the things we're already trying to do, on top of retrofit, on top of designing more lean, things like that. Are there any particular areas of research you see going on at the moment that you think that's going to be the next thing that's going to come into common practice, that's going to start to sort of help give us another tool from the toolbox?
Yeah, I can give some thoughts. Well, first of all, I wanted to say, if you are in practice and you're not involved in university level research, then send somebody an email and get involved, because the work that we do at universities needs practical implementation. There's not really much point me sitting in a lab in Cambridge fiddling around if nobody actually does it in practice. So if you're not involved, please do get in touch. Academics generally love to hear from people that aren't academics in the nicest possible way. So that's the first thing. And I think in terms of actual projects, which I think are going to make a big impact now, it's those projects, and I won't name any specific ones, but those projects which are joining up the design process, which we all go through, the grasshopper, the rhino, all of that stuff, all the way through to the fabrication and the manufacture, and then what happens at the end of life. And so in projects where you just have optimization on its own, you end up with something you can't build. So you need to make sure that's kind of end-to-end linked up, so that we have off-site manufacture, on-site assembly or robotic assembly, and then we know what's going to happen at the end of the life of the building. So that's one important thing. And then just to pick up on the reuse discussion earlier, there's a lot of interesting work which follows the mantra of form follows availability. So rather than taking your blank sheet of paper and designing a building, that kind of philosophy is almost dead, hopefully dying. And we will start to design our buildings from a library of components that have been deconstructed. So you have what's available. And the classic example is deconstructing electricity pylons. You've got a kit of angle sections and you want to turn that into a truss. How do you do that? You're reusing stuff in a clever way. So there's a whole field around that reuse, but clever reuse, informed by what we actually have. And if we are going to go down the reuse of existing infrastructure road, which I think we need to, that's going to become a big part of the work that practicing engineers do. So again, this is happening at universities, but we need people to put it into practice. If anybody works for Amazon, I think Amazon have got a potential cornered market, because they've got warehouses, they've got logistics, they could potentially take apart buildings, store them, scan them, catalog them, and you just assemble your new one from them. So maybe I shouldn't say that. I should patent it.
Even rich. Yeah.
Not give it time, but yeah.
I really like the idea of people taking apart pylons and then turn them into something else. I've not come across that before. Is that a piece of research that's being done?
This is EPFL, so it's the Structural Exploration Lab at EPFL, a guy called Corentin Fivet, F-I-V-E-T, and one of the examples is electricity pylons turned into trusses. So you don't end up with a truss with constant depth. It might be varying at the bottom, but constant on top. But it's a funny shape because it's what the pieces you have are available.
Interesting. No, that's really interesting. And in terms of sort of, so moving up forwards with the sort of, innovation and what's coming next, the other thing we see a lot of at the moment, and I'm sure if any of you have been up to the green zone, you've probably been bombarded by people trying to advertise their products or their solution. So we're seeing a lot of low carbon concretes and low carbon cements and low carbon steels and this and that that's better than what we had before. I mean, I'll start with you, Natasha, because you're closest to me. I mean, what are your thoughts on this? Is it a good thing? Is it, how do you work out which is useful and which is just sort of greenwash? How do you approach stuff like that?
So healthy skepticism on the first point, but then actually just talking to those manufacturers and understanding exactly what they mean by zero carbon concrete and things like that. There are some which are better than others, and I think that's where I think that the IStructE can really help with having that kind of verification for different materials out there. I think, like with the calculating whole life carbon, that was only released last year, and even now we've seen quite large changes in the landscape for lower carbon materials. So I think that the kinds of embodied carbon figures that we're going to see with these kinds of materials, we're almost going to have like a little update year on year, every 6 months. Well, it depends on how quickly we can turn it around, probably year on year. And I think that they do have a place because it shows that, you know, our supply chains are improving. However, they're not absolute zero yet, unless we're reusing this, you know, it's not absolute zero yet. So I think they have a part to play, but we can't rely on them. And I mean, it's about designing efficiently, interrogating your loading, interrogating the brief. It's about using the materials that you are going to design with appropriately and with care, and actually treating those materials as precious, because they definitely will be, you know, in 2040, 2050, and we need to start treating them much more with much more care, for sure.
It sounds like you're sort of saying as well that even if low carbon concretes and low carbon this and that does exist, it shouldn't really change any of the other decisions you have to make anyway.
Exactly, it's all cumulative. You know, if you're going to use low carbon concrete, it doesn't mean that you shouldn't design efficiently. You should design well as well with that. Yeah, for sure.
Steve, John?
Well, I mean, I'd kind of just touch on the fact that, this is something that an approach that you take with existing buildings, but it's also equally relevant for new buildings. It's challenging the requirements. You know, with existing buildings, one of the things that we often have to think about as structural engineers is the loading. You know, what are the loadings? And you know, you can, if you have an existing building, sometimes, especially where there's a change of use, that the loading increases. The sort of simple approach is you look at codes of practice, and you know, you might come to the conclusion that you have to strengthen your existing building. You know, the structure needs to be enhanced to support those loadings, and that can cost a lot of money, that can take a lot of time and effort. And it is a solution, but it's a kind of blanket solution that isn't really the right solution. You know, if we're talking about minimizing materials, if you have, say, a concrete structure and you need to wrap, you know, fiber reinforcement or install a jacket around the columns, and you have to strengthen the slabs, that's all extra material. And a better approach is again, you know, I talked at the start about challenging the brief. It's understanding what loadings are actually required. You know, is it, say for example, it's an office. Is it the codified office loading, or can an acceptance be for a reduced amount of loading? And you know, this is one way that we can justify the reuse of existing buildings. But equally, that approach can be applied to new buildings. You know, and I do also work on new buildings, and often the client's brief will say, you know, give us unlimited flexibility, future flexibility. And this is where challenge that, you know, what do you actually mean by future flexibility? Does it mean that you design every single floor to carry, you know, heavy hospital equipment, or can you, you know, refine that brief? And you know, I've worked on a project where we were kind of defining that brief and saying, well, how about we design these floors that can accommodate higher loadings, you know, X-ray machines or whatever, but we're not saying that we're designing the entire building for those higher loadings and higher vibration requirements. And this is where we're actually defining the brief. You know, we're setting the parameters, and what that will result in is that will result in more efficient structures. That way we're using less materials, where, you know, we're optimizing the structure by making those key decisions. And, you know, this is something that I often do with existing buildings, but like I said, it is transferable to new buildings as well. And doing this by challenging the brief, we're able to optimize the structure in that clever way.
Yeah. John, do you want to?
I mean, just very quickly on that point, then I come back to materials. The classic example is London offices being designed for 5 kPa, which is bonkers high floor loading. The Eurocodes have said 2.5 kPa ever since they were introduced, and yet there's a practice of doing it at 5. So there's loads that we can do in that space. But just to come back to the materials, I think for everybody thinking about doing a life cycle assessment of a building, choosing an EPD of a specific product that you've seen at COP, a low carbon concrete or whatever it happens to be, I would advise not doing that. You want to be using consumption average data, unless you can guarantee 100% that the product you've seen at COP is going to end up in the building that you're designing. And I would say most times that's not something you can guarantee. Then I wouldn't be using specific EPDs, because you're at risk of cherry picking the data. That's the first thing. So using consumption averages means that collectively as a whole, we're on average correct in terms of carbon emissions. Some people will be less, some people will be more. That's one thing. The second thing is about scale. So you'll often find that steel manufacturers are selling a green version of their product, not actually green, but a sustainable version of their product.
Get them to paint it.
Get them to paint it.
Well,
And if you look, they'll say, I know one statistic off the top of my head, 600,000 tons of this material in 1 year. It sounds a lot, but actually from a global perspective, that's 0.03% of all steel being made. So it's a nice thing to look at, but the reality is it's not making even a tiny dent in the amount of steel we're making. So that's not to put down the steel industry or particularly the cement industry. It's just to be aware of the scale of the materials that we use and the supply issue that we have. So yes, there are some low carbon versions of things, but can you get it at the scale that we need?
And there is a IStructE paper on that particular topic, and that's where I think that obviously the IStructE needs to help with this verification.
Yeah, good plug.
Area.
Thank you.
You're welcome.
Yeah, there's IStructE data available on all of the topics discussed this evening. Most of it's free. How about timber then? So okay, we've talked about cement, we've talked about steel. We're seeing more and more engineered timber. It's still far more prevalent across most of Northern Europe than it is in the UK. Natasha, maybe do you want to start? Where is this going? Are you seeing more of this in your work? Do you think it's just going to be the death of steel and concrete, or
not? So what do I think? I think that timber definitely has its place. The reason that we still use a lot of steel and concrete is because steel and concrete are sometimes in the right places, the right choice. However, I think a lot of the time timber doesn't even get into that conversation. We are seeing a lot more timber being used, and actually rather than CLT, we're trying to now push for more efficient uses of timber in that way. A CLT deck is essentially a big solid, block of wood. You wouldn't do that with steel. With steel, you have your efficient sections, you have your I-joists. What's to stop us from using timber I-joists with an LVL skin top and bottom? That's a much more efficient use of timber. So we are seeing a lot more timber, and we're starting to see, I'm starting to push more, an efficient use of timber as well, not just using CLT decks as our standard kind of floor plate.
So it's a quote the great Jane Anderson: more buildings in timber, not more timber in buildings.
Exactly. Correct.
It's really interesting because no matter which material we just touched on, then you've all just come back to use it efficiently, be clever, be thoughtful, don't over design, don't overload it. Are they these are underlying principles, right, regardless of what you're working with. And I guess the point that's sort of coming out of this is that even if somebody's offering you a magic low carbon version, whether it's because it grows out of the ground in the first place or because it's got things substituted for the really high energy stuff, it doesn't get rid of the fact that efficiency is still going to be.
For sure. And I think with timber, there's a temptation amongst some people to look at the sequestration, which happens before you chop the tree down, as being negative carbon, which I guess you can view it that way, but not to forget that at the end of the life of the product, the emissions can be released again. So timber is a temporary storage. It's like a battery of carbon. So it's not permanent unless the timber is kept forever, which it is unlikely to be. So at that beginning stage of the upfront carbon comparisons, don't forget what actually happens over the life of the building. That's the first thing I would say. And then the second thing is, in all of these conversations, choosing between steel and concrete and timber is about doing the calculation and seeing which one in that context makes sense. If you're in Canada, I would say that there's probably a good source of local timber, and you might even have a CLT mill just around the corner. If you were in Saudi Arabia, you might not want to ship CLT panels across the ocean and the land. That wouldn't make sense. So every project should have a different correct or least worst answer. And so I would never say always use concrete, always use steel, or always use timber. I would say always decide between them based on the calculation over the life of that particular asset, and then you have a starting point.
So make a good engineering choice based on the brief, which is in theory what we all do for a living on every other decision anyway. So should be well practiced at it. I want to move on to reuse specifically. Obviously, Steve, you've mentioned it a few times already, which I'm very glad about, but I think we should give it its own sort of 10 minutes for a minute. That was a weird sentence. In your experience, so you talked at the start quite passionately about the need to encourage more reuse of buildings. You talked about, the fact that we've, what was the statistic? 87% of all buildings that are here are still going to be here in 2050.
Correct, yeah,
which is almost all of them. What can we do? What can practicing engineers do to encourage more reuse and help clients make those decisions?
Well, I think, like I said, that a big part of it is looking around at existing buildings, looking at what other people have done and what they have achieved, because you can actually achieve some quite amazing results with refurbing and retrofitting existing buildings. It's looking around, it's accepting that reuse isn't a compromise, and I think I've worked with a lot of clients before where, they kind of think, oh, refurbing it, that's going to be rubbish. But actually, it's we have a role to play to kind of excite them and enthuse them and inspire them into what can be achieved. Like I said, looking at other examples, looking at what you can achieve, but also there are other aspects as well. And some clients maybe are less interested in the carbon story, and they're more interested in the cost and the time. And again, there are other angles as well. So with retrofitting existing buildings, often you can bring that building back into life a lot quicker than it takes to demolish and rebuild. If you've got an existing building, you've got to deconstruct it, you've got to demolish it, you've got to potentially extract all of those foundations out of the ground. That takes a lot of time and effort. You've got an existing building, it's already there, all of that's in place. And really good example is One Triton Square. A lot of people are talking about this. This is a building in London. It was built in the 90s. It was a 7-story building, and we effectively added 3 extra stories over the top of the building. That increased the lettable area by 70%. The amount of time it took to build that was so much less than it would have been to deconstruct and demolish that building. So it's a fantastic story. And we talk a bit about the circular economy, about reusing components. I mean, that was a fantastic story because the facade itself was deconstructed and refurbished and then reinstated. So the carbon story behind that building it's just phenomenal. And again, look at examples, look at where it has been successfully achieved, and then use those examples to have those discussions with the clients. I think that's where we have a role to play, to really excite them and create that buzz about retrofitting of existing buildings. And I think we will definitely see that. I've definitely seen a massive shift recently, and I'm finding that there are more and more clients that just want to explore the possibilities. What can you achieve? So like I said, it's looking around, look at these great case studies that are out there and use them to start those initial discussions with our clients.
It must be interesting for you because you've spent a lot of your career dealing with existing buildings before you had rooms full of structural engineers talking about carbon. Right. So in the past you've had to justify this based on costs and time and ease and things like that anyway, and that's not changed. No, it's if you've got the carbon story as well now.
Well, I think, and that's where clients are slightly more interested. But like I said, it's the time scale as well. How long it takes to bring that building back into reuse. And another really good example is it was the George Green Library at the University of Nottingham, and it was it's a relatively modest building. It was a 4-story building, but the client's brief there was it was a competition, and it was just about keeping the building operational throughout the entire works. And the brief was they wanted to create a dynamic, exciting space that was light and airy, it would meet the modern requirements for today and the future. But they also had this existing facility that had to remain operational. And what we did there is we built a level below the existing building, we built over the top, and then we extended to the side. But throughout all of those works, we kept that building operational. So, there was no requirement for temporary accommodation. There was no need to decant the existing building into some temporary housing. It was all done on live in that, on the campus. And back then, the client wasn't really interested in the carbon story, but if we did the calculation today,
then it would obviously.
But their driver there was about keeping that building. They wanted the facility to be operational, and we came up with a solution that meant the building was retained, it was reused throughout the construction process, and it delivered the project in less time than it would have been to demolish and rebuild. So again, looking at examples and just having those discussions with your clients, what are their drivers? And that once you can understand what their drivers are, you can then see if there is a solution that allows the existing building to be retained.
So it's a slightly different skill set, isn't it, to the skill set of here's the brief, here's the architect's plans, can you make it work? And John, I'm interested to know, like, when you're teaching these young, impressionable undergraduate students all about what structural engineering means, has that started to change? And do you talk about reuse as part of those conversations these days?
The quick answer is not at the moment, but I know that people are starting to do that. So in Cambridge, we're just about to start a new tripos, a new degree program called the Design Tripos, and part of that will be very much around reuse. Yeah.
And how are you planning on sort of instilling some of this on students?
I think it goes back to what I said about that blank sheet of paper. When we take students in now, we start from a blank sheet of paper, and then that's the process of design that people understand. And if you just turn that around and start from what we already have from the beginning, to the first time you encounter a design problem, you're doing a reuse problem, it becomes natural to do it.
It's funny, isn't it? Because like the 101 task you always seem to get given is the one where you roll up newspaper, stick it together with sellotape, and you have to make a bridge or something out of it. Where you've already been given all of the constraints there as to what you can do. And yet that's always been a sort of standalone, team building in first year of university exercise. But it's entirely that way of thinking, isn't it? It's here's a kit of stuff, build me something out of it. Yeah. I think personally, I'd be really excited to see, graduates being taught this sort of stuff, so that when they get into the workplace, they're able to turn around to Steve and say, well, hang on, that's not good enough.
No, absolutely. I guess the only downside to universities is our time. Somebody starting university this September has got 4 years ahead of them, and then we're only 4 years left for 2030. So
all the more reasons to
everybody needs to educate themselves about reuse, not just it's not just those who are 18 or 19.
Yeah, I agree.
Yeah, and I guess just to add to that, with what I found with reusing existing buildings and retrofits, it does require a different skill set. That you need to be able to technically be very competent, and you may need to back analyze existing structures. You need to understand how it's working. And it's really challenging because it's very different to how you design a new structure, because you have that blank piece of paper, and then you carry out a design and you develop a model, and then you analyze it, etc. With an existing building, you have to start from there's something there, it's standing up. How's it standing up? I need to, you kind of need to figure out a strategy, and then you have to open up, and then you may find that your initial assumption was incorrect, and then you have to scratch your head a bit more and then try and figure out what's going on, how is it working. So that, and that's kind of just, again, it's just resetting how you think about structures and buildings and how they work, because you really have to challenge how you think it could be working, rather than I need to set up a model and analyze it to death. And this is where it needs that engineering judgment. So that's a different skill set. But then it's also important to understand all of the other disciplines. It's not a linear process. It's not about just the structure. You need to understand the wider picture, because there will be building services that need to go into the building. How is the existing building working? How are those services threaded through that building? And it's kind of understanding what can be adapted. Can you utilize existing risers? Can you use penetrations through the existing beams? And again, it just puts a slightly different spin on it. And I worked on an existing building where we found there were laboratories on the floor plates, and when we stripped out the ceilings, we found that there were penetrations through the beams, and there were trenches within the floor. And that was great, because you could suddenly then change the M&E strategy, the building services strategy, to thread through that existing fabric. We're not making new holes. We're able to maximize the floor to ceiling height. So it really improves the space, but it requires that close collaboration, working with the other disciplines and exploring those ideas. So it's a really different skill set to, the architect comes up with an idea, you design something, and then, put it into a model and it spits something out. This is more about that, that iterative process. And
I'm maybe going to challenge you on that then, because actually what I think you're describing isn't all that different to you know, just good close collaborative design, because you know we all know that design doesn't follow a particular linear path at the best of times anyway, and that there's design and redesign, and it's pretty common to be halfway through building something and have a new better idea. So to me, actually, it sounds like there's quite a lot of parallels. It's just that maybe there's this extra input coming from new data being found on site, say, instead of where the only inputs are maybe the clients changing their views, or the architects coming with a better idea. I mean, Natasha, like when you're doing like new build stuff with grads, and then all of a sudden you take them and you plonk them on a refurb project instead.
Yeah.
I mean, do they adapt to it? Is it such a different set of skills that you find that they kind of can go with it?
Well, it depends on the level of support they get, but also I think that, you know, physics is physics. And whether it's a case of we start with a model and then make something, or if it's we start with a something and then make a model, I would say that yes, I've seen quite a few similarities there. I think it's just definitely the understanding of what to put into your model, and understanding the kinds of surveys that you need for this kind of thing are the really key thing. Our grads are actually just really keen to for reusing projects. I mean, a lot more of them are so much more switched on about embodied carbon and sustainability and equity, probably more so than definitely when I started as a grad. And if anything, I think that they're a lot more wholeheartedly keen to get involved in reuse projects than they are in new build, because of that as well. So.
Yeah, it's interesting. I find that when I go and speak at universities, I have to remind myself that who I'm speaking to is quite a different audience, and they usually know half the stuff you want to tell them about. You do know that levels of carbon are going up and we need to get it down. And they kind of go, yeah.
Can I just add one very quick thing about this, which is the reuse side is actually, from a pure structures perspective, the much more difficult bit to do. The reality of most new design is you design it, do a computer model in STAAD or something, somebody builds it, and you never check if the computer model was right, because you frankly wouldn't want to. The difficulty comes when you try and assess what's actually there. And I'll give you an example of a beam that was tested 6 years ago now at University of Toronto. 19-meter long reinforced concrete beam, 4 meters deep, one load applied to it, simply supported beam with a point load applied to it, very simple structure. Before they tested it, they sent all this around to everybody in the world who wanted to predict this performance of this beam. They had 66 responses, I think, 33 from industry, 33 from academia, ranging from 250 kilonewtons to 3.8 meganewtons as a failure load, right? So first of all, that tells us we don't know what we're doing. And it failed at 685 kilonewtons. I remember this, but I tell this story all the time. But even for something as simple as a simply supported beam, that's not of a scale that we don't build, 19 meters long by 4 meters deep, that's not that unusual. We really struggle to predict behavior. Okay, so that's when, coming back to the reuse scenario, actually knowing what the real capacity of your building is quite difficult. And that's where the interesting bit lies. So it's super easy to do a model that you never check, but to do a model that's realistic is much more.
Yes, and that has to be the closest approximation to reality you can get it in order to understand it. Yeah,
we did. We did a retrofit for a 1930s concrete concrete hangar, and it was me and a colleague was stood on the roof, kind of bounced up and down a bit. I was like, okay. But then we tried to make it work mathematically, and we're like, well, it's just stood up, so we'll take the load of both of us, and you know, that's a safe working way.
Yeah, sure.
So it was quite yeah, it was very difficult to predict.
Yeah, I mean, I live in a house from the 1740s. I mean, the floors, it's quite horrible. I mean, your bedside table nothing straight anywhere. There's no way you could justify it, I don't think, to modern codes. And just trying to predict, you know, trying to work out load paths and stuff like that, it is just so much harder. But it all comes back to what you're saying before. 87% of the buildings we've got now are still going to be here. So you just have to learn how to do it, and you have to make that part of your work thing.
Yeah, but it is also a slightly different approach as well. And you know, with existing buildings, especially very old buildings. So you know, I've designed or assessed existing buildings that were over 100 years. And there is an approach that you can take where it's called the 100-year rule, where if the building's been standing for 100 years, it should be okay, because it's had the test of time.
We'll cut that out of the
but I mean, this is where it requires a different level of skill, because I was working on St Pancras Chambers, so this is the hotel next to St Pancras Station, and we're adding in extra load onto the building. We're putting in new floors, and we did a load balance. And I think if you do the numbers, it was quite difficult to justify that it could carry the weight that it was carrying. But again, so we use this 100-year rule where it did require extensive opening up works. It required surveying and inspecting the structure to ensure that it didn't show any signs of distress and distortion. And we were able to justify and satisfy ourselves that it was fine. And equally, I've worked on another project where it was a Victorian building built in the the 1800s, and what had happened is that there were some large cracks and there's what looked like some significant movement. And what we found is that the movement happened almost immediately when the building was constructed, and then it stopped moving. So what happened is the building was constructed, it settled, the building cracked, and then it just carried on performing as it was. And the discussions that I had with the client there was, we could try and underpin it. That will cost an absolute fortune, and even if you underpin, you might create more problems because you're creating hard spots. And we're able to justify a solution where we said, well, actually, you're better off to just monitor parts of the building. Where we were changing the load, we accepted that we needed to enhance the foundations, but for the existing building that wasn't seeing an increase in load, we're able to satisfy ourselves that actually it's not a good idea to put in new foundations or take parts of the building down, but just monitor it. And it was a practical solution that was cost effective. But again, it's slightly different, because if you were to model that, you'd say, bloody hell, this is going to fall down. And and this is where it does need that engineering judgment, and it needs a slightly different skill set, not just plugging it into a model and seeing if it's green or red and
you do need to build some experience to make these calls. I'm going to try and move us on, because we're going to start taking questions in sort of 5 minutes or so, and there's kind of one more area I wanted to try and get in there before we do that, and that's about sort of practical actions that structural engineers can start to take on their work tomorrow. We do still have one day left this week, so tomorrow, not Monday, tomorrow. So in terms of low-hanging fruit from a carbon perspective, it goes out saying retrofit obviously features quite highly up there. Natasha, after reusing what we've already got, what would you say comes next? What would be the top thing somebody go out and sort of pursue tomorrow?
I mean, apart from challenging everything, it's target your floor plates. If you can save any material on your floors tomorrow, because that's quite a specific, nice targeted space to be in, look at that.
Why floors?
Why floors? That's because columns and beams to an extent are quite efficient structures. Columns, definitely, they take the load straight to ground. But floors, as well as supporting load, kind of stop us from falling to the floor below. So there's a lot of, they serve another purpose. So they're, by their very nature, they are quite inefficient. If we wanted to be super efficient with how we get around on the floor in a building, we would walk along lots of different beams rather than necessarily like a floor. And because there's a lot of material in them, any even modest savings that you can make there will definitely reap quite large fruit.
Because they're holding themselves up as well as everybody else.
Exactly. So if there's one thing you can do tomorrow and then probably finish that task tomorrow, it might be look at your floors.
And how much of the carbon in a building is it? This might be a question you don't know the answer to. How much of the carbon's in the floors?
It depends on the typology, but it's typically between 35 and 45%, I think, between offices, residential and schools. 35 to
45% of the structure or of the whole building?
Of the structure.
Of the structure.
Yes.
Okay, so just under half of the whole structure's carbon emissions is the floors.
Yeah.
And it's one thing, and typically, I don't know about you, but if I was designing a composite deck, I used to pick the one I did on my last job and say, that'll do, and move on. And like you say, if you can shave 25 mil off the whole floor plate. It
Exactly.
adds up pretty quickly.
I think I did a calculation, which was if you could save 25 mil off the floor of a concrete building, which might be a 6,000 meter squared office, that's the same as someone going vegan for the rest of their life. So, yeah.
So if you like meat,
Exactly. If you like meat, have your skinny floors.
your skinny floors. Yeah, yeah.
I have the workings as well. I'll share it with you
Yeah,
if
if
you
you
want to
could,
see.
yeah.
Yeah. Cite
I'm
my
sure it's
sources.
right. John, I mean, do you have a sort of like thing for people to take away tomorrow?
Thing for people to take away. The thing that I kind of noted down is perhaps something that you may well know, but for me, it put climate emergency in perspective. And it's that, and this is related to glaciers in particular, so slightly away from Natasha's point. It takes the same amount of energy to melt 1 gram of ice as it does to increase 1 milliliter of water to 80 degrees centigrade. So melting ice caps is terrifyingly huge amounts of energy.
So it's as energy intensive, nearly as boiling a kettle.
Nearly, yeah. Just to melt a gram of ice, to melt ice, so ice to water is the same as water to 80 degrees centigrade. That's why melting ice caps is so worrying. And I only found that out recently. Yeah. I thought I'd share that with the room.
So yeah, scary fact.
Yeah.
Thank you.
But yes, my main message would be, if you're going to go away and do anything, then understand what safety really means. So read Eurocode 0, cover to cover, and then make your carbon calculations as important as that.
Okay.
Yeah.
Good.
The more practical thing to do.
And Steve, I'm going to challenge you not to say the word retro. No.
Well, no, I think there are two things. So one is that if you are having those early discussions with your clients, or you have a new project, which does involve new build but demolishing an existing, it's challenging, and going back to the client, to have those discussions. Is there an option? But I think that's very specific for a new project and requiring an existing building to be removed. And the other thing is, just like I said, look around. It's really important to look at what others are doing. And again, the IStructE has loads of good case studies of projects, and I think it's just having that armory of projects that have achieved these fantastic carbon savings, so that you can have those discussions with the client, because that way a client may actually see something that resonates with them. They may, not all of the projects will be like Coal Drops Yard or St Pancras Station or whatever. They might just be relatively modest, small 3-story concrete structures, and it's just seeing what you can achieve with even relatively simple, straightforward structures, but how they can be repurposed.
I think look around at the moment as well, beyond even just structures. It's worth remembering how quickly the industry is moving at the moment on this whole topic. I mean, over the course of the last 6 to 8 months, there's a few really big engineering firms that made commitments that they just wouldn't have imagined making 20 years ago, in terms of calculating carbon on everything, or aiming to reduce carbon by such and such percent by such and such a year, and keeping up with this change is quite hard. But I do think it's worth trying to sort of stay abreast of what are the other clients who I'm not working with saying, because maybe that will give you a story you go to your client with. What are other architects who I'm not working with, what are they doing? So again, to sort of help the conversation move forward, because I don't think you want to get left behind, and it's quite easy to do so at the moment, I think I say. We're going to open up to questions. We've got questions online as well as in the room. So you have to fight to put your hand up first, because I imagine we've got a few coming in online, hopefully. But any questions in the room first? Would you mind standing up and saying your name? Because I'm going to have to repeat this into the microphone, otherwise people online won't know what you've said.
My name is Seamus Phillips, structural engineer. I work mostly with historic buildings, so the question is slightly related to that. What are your thoughts on building lifespan for new builds? We have a lot of historic buildings around lasted for hundreds of years quite successfully, and those are what we're using for retrofit. And they're all quite redundant structures, and so they're quite suited for retrofit. And when we're looking at new builds, I struggle to see that a lot of the new builds that are going up today will last several hundred years. And especially when we're talking about increasing efficiency in structures, like thinning it right down, are they actually going to be reusable in the future? Are they going to last several hundred years?
Okay, thanks. So the question was sort of, lifespan of new builds, and do they have enough redundancy, enough extra robustness?
I can
John, do you want
give
to-
a few thoughts. So I happen to work, my office happens to be 400 years old, and we've just in my college built a new library, which we hope will last for 400 years. So there are projects around that are set out with a long lifespan. So I think that's the first thing. The second thing is demolition or deconstruction often happens because things have fallen out of fashion rather than they're not serviceable. So there's a question about why we're allowing fashion to dictate what we're doing. And in terms of redundancy, I mean, structural redundancy, every building has lots of structural redundancy, I would hope. Otherwise it'd be a mechanism and that would be bad. And so that exists, but I think your question was more about things like loading and efficiency. And for me, something like a floor load of 2.5 kPa is sufficiently flexible to do all sorts in the future. You can turn it from offices to flats and back as many times as you like. You can do other things if you add strengthening and so on. And so I don't think it's a question of adding material now just in case in the future you want to do something. I think it's designing with as little as possible now and then being clever in the future because of the carbon emissions are all about time. So the sooner we cut emissions, the better. That's the key thing, is that the longer emissions are in the atmosphere, the worse they are for us.
I think we have to remember as well that if we make a decision that might save carbon in the future, it's at best it's still going to be a maybe. Whereas if that decision results in increasing emissions today, that's a dead cert. It's definitely going to happen. And so you've got to get the balance right. I wouldn't say that there's never going to be situations where you make the judgment to increase emissions a little bit today, because there's a very high chance you can save a lot of carbon later on. And there's guidance out there. For the GLA, Greater London Authority, have got this really good diagram on the website. There's a sort of flow chart of decision making when it comes to reuse and adaptability and stuff like that. And the sort of advice they give is if it's very likely the use is going to change within 5 years, then you design for it to be flexible, as it were, which might mean adding a bit. But anything more than 5 years, you design it so it could be adapted. So you think about, well, how could an engineer come back to this later? Could they stick FRP on the underside of the concrete? Could they weld more steel to the steel? But yeah, it's interesting. They take that 5-year time span and put it in there. Next question. Who wants to go? Hand up at the back. Thanks.
Just one interesting point regarding composite metal floors. You talked about floor slabs being 40%. In all buildings that I've ever been involved in with a composite metal floor, they span on 2.5, 3 meters, so they don't need any propping. If you actually put propping in the middle of that, you can double the span for the same amount of material because you don't have to carry the dead weight of the concrete. Better than that, you can use precast concrete that can span 9 meters, same thickness, but it's got the cores through it, so it's got a lot less steel and can span much further. So you can make positive steps there to actually save hugely the amount of concrete in a floor slab. The other thing on new build you mentioned, the most efficient thing on designing a building is actually the grid.
Yeah.
When I started off in structural engineering, 9 meters was a sensible grid. All buildings are now 15 meters, massive. You've doubled, if not trebled, the amount of steelwork that goes into the building, because all clients want the maximum flexibility. If you actually go back to more sensible grids and more cellular buildings, they would last much longer. So that's my 2 observations on 40 years working in the industry.
I think very good observations. And just to repeat them for people online, the first observation was about, composite deck, the savings you can make through propping, the savings you can make through going precast, they're all there for the taking. The question is, why don't we do them? And the second
speed of construction that drove that, but that's going to save carbon.
That's going to save a lot of carbon, and it's the source of observations of things we should be pushing for with our clients, because that's why they're employed us. I think, does anybody want to come back on this? So the second point was around grids and how they have increased over time.
Well, I was going to say, it kind of links to what I was saying about having those discussions with the clients, because I find this with new build projects as well, where the clients want that flexibility, and I think to date, because we do it. And if the client says, I want a 15-meter clear grid, as you suggested, we can do that, we can achieve it, so we just follow suit. This is where, again, it's really important that we challenge the brief and those requirements. Do you really need 15 meters clear span? what do you understand what that means? You know, that 50 meters is massive, and you could accept a column on 9 meters, and actually it's perfectly acceptable. So I think we do have a role to play to challenge that, and you know, especially with the carbon angle, you know, by reducing the span, we are having a much more efficient structure that uses less embodied carbon.
Yeah,
So
I think a lot of people could definitely fit their own flat into a 9 by 15 meter grid without any
Exactly.
problems at all. Like, it really is that big.
Yeah.
Natasha, did
Yeah.
you want to?
And also
So-
floor to floor is rocketing.
Yeah.
You know, from 3.5 to 5 meters.
Yeah, and it all just adds, doesn't it?
Yeah, it's
Yeah.
just got to get heated and, you know, conditions.
So we've just actually gone back to stage 3 on a project, which was a 7.5 by 15 meter grid, and the floor plates in them, when you actually looked at the architectural makeup, they were sectioned off into a bit more human scale spaces. So where was the benefit necessarily of that 15 meter span? And it has now been reduced to a 7.5 by 7.5, and we have made substantial embodied carbon savings, around about 50% on the structural grid, on the superstructure and substructure. Another reason that we saw an increase as well is BCO guidance from 2014 had 7.5 by 7.5 as a minimum grid. BCO guidance 2019 actually changed to the minimum grid size being 9 meters in at least one direction. And I think that maybe when they made that change, they weren't aware of the massive impact that grids have on our embodied carbon. And whenever I give these kinds of discussion and presentations to architects and other structural engineers, mainly architects, sorry, it is something that they're unaware of as well. And I think that there's a lot to be said for you know, the kind of visuals that you use to sell a space. If you sell your space with these very skinny, very far apart columns, then you feel inclined to deliver that. Whereas, you know, a column isn't a bad thing. Have a column.
There's a really nice piece online. I think it was
Exactly.
written by Andy Yates, but I might have got that wrong, about, you know, celebrating the column.
Exactly.
And going back to, if you go to historic buildings, I mean, the columns of the art, they're absolutely celebrated. You know, think of like the ancient ruins in Greece and places like that. You take the columns out, you're left with this complete blandness. So yeah, celebrate
Exactly.
columns. I'm going to add that to the list at the start. I'm going to take another question from in the room, and then we'll take one online, if that's all right. So gentleman at the back with the hand up high. Yes.
Yeah, my name's David Miller. Andy got dragged me here, so it's his fault. This panel's been brilliant, really interesting. I'm not an engineer. I work for an organization in 40 cities, which is a coalition of mayors of the world's largest cities working together to help avoid climate catastrophe. Our mayors are really keen on the built environment and trying to be extremely active in showing leadership to dramatically reduce emissions. I'd be interested in what the panel thinks mayors who have regulatory authority and those who don't, who simply have their convening authority, should be doing today to help speed the kind of transition you've been talking about during the point.
Thank you, David. So the question was, you know, for mayors, for leaders of cities who have authority over what happens within that city, what could they do to speed up the sort of transition that we're talking about? And so I'm going to chip in with my own thoughts on this to start with. In the UK, there's been a lot of progress in London compared to the rest of the country. So in London, the Greater London Authority now require you to undertake a whole life carbon assessments for major projects and report it. They haven't yet set hard, firm limits beyond which, if you exceed, you can't build it. But it's the obvious first step is just getting you to report it. And I think that actions like that make a massive difference, because you think, well, it's only reporting it. But of course, what then happens is, well, people want to do better. And once they start to understand the numbers, they then want to see where to go next with it. So if I was to be able to say anything to mayors of the world, it would be just take that first bold step of making people report carbon on everything they do. Because as John put it, then you're making your carbon calculation as important as your safety calculation, and it just elevates the status of it, and then everything else begins to follow. But do any of the rest of you?
Yeah, no, I completely agree. It's partly the planning system. So in the UK, making sure your planning system has a requirement for a carbon count in it. That would be a simple thing to do, or to demonstrate whole life carbon assessment, as you said, in London. I guess the other thing which I'm interested in, and we've seen in the built environment, is taxes. If your mayor has the ability to set taxes have always shaped the built environment, from the narrow houses of Amsterdam to the kind of mansard roofs in Paris, that kind of thing. That's all tax-based. So it's always money. So if you have the power to tax people, you can help shape it. So planning and taxes, definitely.
The interesting thing I found, so one of the initiatives we started earlier in the year is something called Part Z, which was a industry written proposed amendment to the building regulations in the UK. And the idea of writing it was to try and explain to policymakers how simple it would be to enact regulation on this topic. And the document itself ended up being about 7 pages long. It's pretty short because it references tools and guidance that already exist. And the point I wanted to make was that actually when we went out to industry and said to people who out there is in support of the principle of what this stands for, almost nobody's turned around and said no yet. The closest we've had is, well, we're not sure we want to put our name to something that sounds a bit too much like a movement and an advocacy group. But except for that, if you go to partz.uk or you Google Part Z, there's about 100 or so statements from some of the biggest companies in the world on there. You've got your Arup, your Atkins, your Aberdeen Investment, your Lendlease, your Grosvenor Estates, all backing this principle, because they're all saying we're kind of doing it already. We want to have this regulation pushed on us, because then it makes us all raise our game and it raises that baseline. So I think the appetite's there, and I think what mayors of your cities would find is actually there won't be very much resistance to this, at least, you know, particularly not in places which they're already hosting conversations like this anyway.
Yeah, I think just to add to that, you know, I think in terms of cities, to date, the focus has been on a lot of new build. And, you know, I talked about 87% of our building stock that will still be occupied by 2050. And a big part of that is residential, you know, and you do see in a lot of different cities where the focus is on new residential developments on greenfield sites. But we've got a load of existing buildings that are poorly performing, and that's both, you know, domestic residential, but also tower blocks. And I think there needs to be a real shift in focus. And I do hope that after these couple of weeks at COP26, because today there has been so much talk about retrofit. You know, I've managed to drop it in almost every single conversation that I've had here, because it's so important. And you know, we understand what retrofit is, as you know, in the built environment. But I think a lot of people outside of the built environment don't necessarily understand what retrofit is,
or necessarily understand what the potential.
Exactly, and I think this is where, you know, we will see that change, because everybody has been today on cities and buildings. Everybody has been talking about retrofit as a key part of it. That suddenly, hopefully, city leaders will think, what is retrofit? What does it actually mean to me? What can it mean to that city? And they'll then look at how they can retrofit buildings. And, you know, with a big part of these large developments, it's the funding and how the funding is unlocked. So, you know, you mentioned about taxing, and I think if that's the difficult conundrum, that's the really tricky thing. You know, as technical experts here, where we can be chomping at the bit to try and solve the problem. But I don't think it's necessarily the technical problem that needs solving. It's how do you unlock the funding so that it's actually viable?
You give the engineers one something.
I'll just add one thing on the tax.
Yeah, sure.
I hope everybody is aware about the VAT situation in retrofit.
Yeah.
So new build construction 0 rated, repair and retrofit is 20% rated. That's a really big barrier. And there is a campaign to stop it. The AJ has been trying to stop this, or stop it, level the playing field. Retro first. It's kind of bonkers that VAT is.
It costs you 20% more to retrofit than it does to build a new building.
Yeah.
My points are
Make your
very
point
quick.
as well, and then we're going to take the question
Very quick.
because then we're going to have to wrap up.
In an ideal world, I'd like to see no demolition unless something's structurally unsafe. I think that's something that a city could do. And also citywide, using materials, using buildings as material banks. I think at a city scale, you always have something that's being done to infrastructure or another building. And I think that at a city scale, you could definitely have the responsibility and have the ability to really push for circular economy principles. If something's being demolished and a new building is being built, get them to speak to each other.
Yeah, far easier than on one product at a time.
Exactly.
Agreed. Right,
Exactly.
we're going to take our last question online. I'm going to have to make it a quick answer because I've got to sort of wrap up for the evening. Do you want to go for Ruth?
We've had quite a few questions coming in about the legislation side of things, and somebody's asked, do we think it's stringent enough? And the London plan requires whole life carbon assessments. It doesn't actually require developers to take action to reduce the embodied carbon. We just have to measure it. So do we feel like the institutions are being radical enough, or should we be lobbying harder for actual hard legislation to reduce it?
So should the institution be lobbying to increase legislation and what it's asking us to do from a carbon perspective?
Yeah.
Does anybody want to provide a 30-second response?
Yes, the institution should lobby for more strict legislation for sure. There are lots of people in that space, whole life carbon, GLA, etc. They all have the same ambition to get to somewhere more stringent. This is, I guess, a starting point.
Yeah.
Better than not having it.
Yeah.
And I think I'd say to whoever asked that question, do go online, do check out the Part Z initiative, which the institution's backing. It's trying to do exactly that. It's trying to get that conversation going with policymakers around the state of where we're at now. It's trying to help explain that the industry is asking for this. The fact that we're getting questions on the topic from the industry just shows that there's appetite for this. And yeah, we will continue to go with Part Z and keep the topic going. I'm gonna wrap up there if that's all right. I'm sure we could keep talking for ages. And on your way out, if you do want to grab us, I mean, we're probably going to hang around for another 20 minutes or so outside. So if you didn't get a chance to, I'm aware that lots of hands went up right at the start. We never got to them. I'm very sorry to everyone online who typed in a question and didn't have it read out. We're short on time. Thank you to our three speakers. What we're going to do just before we wrap up is I'm going to invite Martin Powell, our Chief Executive, to say a couple of closing remarks. And then there's going to be a brief video played on the screen. And then after that, you're free to go and applaud our speakers for their time, so on and so forth. But firstly, over to Martin for a couple of words.
Thank you, Will. And firstly, can I invite you to give a round of applause for leading us through. I'm very conscious you've been sitting, listening and engaging, and probably have still got an awful lot more questions that you might like to grab the panelists. But first of all, I'd like to thank the Scottish Regional Group for hosting us here this evening. It's been such a marvellous opportunity to piggyback what's going on with COP, to be able to have our own fringe event and align it at this time. If I said to you that the greatest threat to the survival of the human race as we know it is doing too little, too late, you might well ascribe that quotation to David Attenborough or Al Gore or someone in the more recent future. Now, I don't know whether he wrote it, but I've got a lovely link here because it was actually used by a former president of the institution who went to this university, Sam Thorburn. Some of you may know or remember. Sam's now into his 90s, and I still correspond with him from time to time. And he wrote an article for a newsletter here at Strathclyde in the early 2000s. It was a personal view on climate change and sustainability. It was a thought piece, a thought leadership piece. But of course, as he was advocating, a lot of that thinking about taking out carbon, putting back carbon, goes back to the 1860s, 1870s. So what's changed now? You know, where is the inertia that actually says, is this the right time? Well, listening to the discussions tonight, seeing the alignment of thinking about the technical development, the thinking, you know, as an institution, even 8 or 9 years ago, we were saying, is the time right now as an institution to be doing far more in the climate change arena? And the answer was probably, but is society, is the world, are things aligned? Well, I would suggest to you in closing these formalities this evening, that there's probably never been a better time in recent past to say things are aligned with the lively minds, with the input of so many people within institution and beyond who are really striving to have the tools, the solutions, the ideas, the thinking. The talk about regulatory framework to enable it to happen. The real threat of that climate realities is such that I would suggest that now is the time for us all to really be saying this is moved well beyond the conversation piece. And I think the challenge as we go away from here this evening is what we do to turn this into real action in the workplaces and in the communities in which we live and operate, whether it be the business orientated side, or as Natasha said, you relate that back to your own personal values as well. So beyond the thanks to you as a group for the discussion tonight, I thank you for again throwing the challenge to all of us to how we now actually really take the tools and the things that are at our disposal to make things happen. So with that, I invite you, if I may, just to hold fire for a few minutes while we share with you a video that's been produced by the institution that hopefully I think rounds things off for us this evening, but hopefully the conversations and the actions really will continue. So thank you so much for sharing in this evening with us. Thank you.
We are experiencing record-breaking storms, droughts, fires, ecosystem collapse, climate migration, which has been brought about by human-induced global warming through years of excessive greenhouse gas emissions, including that from buildings and construction. As these storms and droughts and fires become stronger and more frequent, they will have a larger and larger impact on our lives. What are you going to do about it?
We will exceed 1.5 degrees global warming around about my 40th birthday, bringing previously unprecedented heat waves to Europe almost every other year. By the time I'm my grandma's age, the world will be 2 degrees warmer, locking in as much as 4 metres of future sea level rise and destroying every beach you've ever visited. Our families and friends are looking at a future of yearly weather cycles, currently thought of as once-in-a-lifetime events. And the financial cost will be measured in trillions of dollars per year. We must prevent this future from happening.
Almost 40% of the world's greenhouse gas emissions are due to buildings and construction. I'll try to put that number into perspective. Most of our personal decisions could be quantified in terms of kilograms of carbon emissions. So if you skip a steak, you save 30 kilograms of carbon. If you avoid flying from London to New York, you save 800 kilograms of carbon. But in comparison, when the engineers, architects and client worked together to save this 1950s building from demolition and enabled its reuse as a high-spec office space, we saved 13,000 tons of carbon. That's the same as 16,000 flights from London to New York. Imagine the impact that could be made if we started making reuse decisions like this on every project. We must take our professional responsibility seriously if we want to make the biggest impact we can on global emissions.
The climate crisis presents not only a threat, but also an opportunity. An opportunity for me, for you, for all of us, to make a significant difference to the future of life on this planet. We can't afford to indulge ego and gratification. It's time to move away from taking pride in being the tallest, the longest, or the most heroic. We can do so much better than this. This is an opportunity to create buildings and infrastructure which, by being the smartest, the leanest, the most regenerative, will make a positive impact on the world. Not just for today's generation, but for every generation after. The Institution of Structural Engineers and our partners across the industry are providing the tools and guidance necessary to do all of this. Our profession has never been better equipped to reduce carbon emissions, and it's never been more important than now.
At the institution, we've been working tirelessly to put sustainability on a par with our enduring commitment to life safety. But for lasting change to happen, this needs all of us. The whole industry needs to raise our game. To drive the change we need to see, each of us must commit to something bold. and we must do it now. It's not the detail that's important, it's the ambition, the level of transparency, and the ability to track progress and strive for improvement. It's time to commit to doing things better.
Global warming will affect us and every single generation that follows us. So when you are asked by your children and your grandchildren about the role you had to play during the climate emergency, what will you tell them?